Okay, this is the video for the Chapter 2 review, otherwise known as the LTA. And I'm going to do my best to work on this without a graphing calculator because you'll be asked to do your test without a graphing calculator. You'll still have access to the basic multifunction calculators. I'll pull those out for you guys, but this chapter is all about being able to have the instinctual knowledge of what your graphs are supposed to look like, how to compare them to the parent functions, transforming functions, all of those things. So with that being said, let's find the vertex of each parabola and determine if it opens up or down. So just to mention, this formula is already in HK form, and the vertex is HK. So you could find your vertex very quickly. It's 8, 4, and it opens down, which you can tell by the leading coefficient being negative. This one here, you could go to the work of completing the square and finding HK form, but we are going to review that the vertex of a parabola is also negative b over 2a. Is the x-coordinate, and then you plug that in to your function to get the y-coordinate. So negative b over 2 times 2. So my x value of my vertex is negative 3/2. So let me put that over here, and then let me substitute that in. 2 times negative 3/2 squared plus 6 times negative 3/2 minus 1. So this gives me 2 times 9/4 or 18/4 plus negative 18/2 minus 1. So let me get some common denominators here. I'm going to go 18/4 minus 36/4 minus 4/4. So I get negative 22/4 or negative 11/2 for my vertex there. And so let's see, let me slide this over a little bit. So here's my answer for my vertex, and then the other part of the question was, does it open up or down? So that has a positive leading coefficient, so I'm going to say that it opens up. So in number 3, I need to sketch the graph of the parabola, label its vertex and its intercepts. So I could go ahead and let's see, what'll be the best way here? I think I'm going to go ahead and get this into HK form just to practice with you guys about vertex form. So I am going to pull out a negative, x squared plus 6x, and then I'm going to leave a blank, and then I didn't pull a negative out of my 8. So I've got 2 blanks there. So I'm going to complete the square. So cut b in half, that's 3, and square it, and that's 9. So I've introduced a negative 9 into my equation, so I want to do plus 9. So my equation is negative x plus 3 squared plus 1. So that gives me a vertex of negative 3, positive 1, negative 3, positive 1, it opens downward and it's not stretched or compressed, so it's going to cross at negative 2 and negative 4. It's going to continue opening downward, and I'm off the page a little bit there. So the intercepts I needed to label at negative 2, 0 and negative 4, 0. And I could plug in those values here which in fact, let me go ahead and do that. F of negative 2 is negative. Negative 2 squared is positive 4. Minus 6 times negative 2, which is plus 12, minus 8, that's 0. And then f of negative 4, plug it in. We've got negative 16. Minus 6 times minus 4 is plus 24. Minus 8 is also 0. So those are verified. Vertex and intercepts. And then as a y-intercept, I'm going to take this equation here and I'm going to say, when is this equation equal to 0? What value of x? Sorry, I don't want to plug that in for 0. I want to say when f of 0. Okay, so I'm plugging that in. 0 plus 3 squared plus 1. Yeah, because my y-intercept is when x is 0, not when y is 0. So 0 plus 3 is 3, squared is 9, negative 9 plus 1, we get negative 8. So this graph here would cross at 0, negative 8. Okay, sorry about that. In number 4, we have a situation, this is kind of like the baseball problem, where you're given sort of a complicated equation that's based on some real life situation, and the annual average per capita consumption of cigarettes by Americans. Okay, so that's the number of years after 1960. Find the maximum annual cigarette consumption. So anytime we're looking for a maximum and we have a downward opening parabola here, I mean, we're basically just looking at, you know, this is some kind of a parabolic shape. So why don't I go ahead and rewrite this in standard form. So in standard form, I want to go ahead and find the maximum value. So that's going to be at the vertex. So I'm going to do negative b over 2a. And I'm going to adjust my camera. So negative b, negative 3.4 over 2 times negative 1.52. So 3.4 negative divided by 2 times 1.52 negative. So that's 1.1, say. And then when you plug that in to your original formula, so 4,274 plus 3.4 times 1.1 minus 1.52 times 1.1 squared equals 4,276. Yeesh. Okay, so the maximum annual consumption was 4,276. Okay, that's just gross. Divided by 365 days in a year. So that's an average of like 12 cigarettes a day these people used to smoke. And anyway, so that was back in 1960, and then 1.1 would represent, like, if 0 is 1960, then 1.1 is actually just 1961. So that's when it was highest, and Then beginning in 1966, all cigarette packages were required by law to carry a health warning. Do you think the warning had an effect? Well, it's a downward trend on a parabola, so I think yes, it had an effect. The graph goes downward after 1961, and actually, more quickly, because remember how exponential functions work. Like, after just 1 year it was 1 squared, after 2 years it was 2 squared, after 3 years it was 3 squared. It's going to be more and more quickly. So that's all I have to say about that. So numbers 5 and 6, we need to use the leading coefficient test to determine the end behavior of the graph. So the parent function here is a cubic, so sometimes I like to just, there's my parent, oh, you can't see that, there's my parent, and so my degree is 3, the highest order degree. This is following the cubic. It has a negative leading coefficient, so I know that that function has the opposite end behavior of the parent. So to the left it's rising and it's falling to the right. So here we have a 7th, which is also odd, but it's a positive leading. So it's going to follow the same end behavior as the parent, falling to the left, rising to the right. So in number 7, we've got this cubic function, and we're being asked if this is a factor. So recall that the way to determine that is to do a synthetic division. And I'm checking my function to see if there are any spots where I might need a placeholder. And it's descending order of the variable, so it does not. And then as I do my synthetic division, I get a 0 remainder, so that says yes, 6 divides evenly with no remainder. And is x minus 2 a factor? Well, let's divide it out. So 2, and I'll go back to the original function, 1, negative 2, negative 20, negative 24. 1 times 2 is 2, 0, 0, negative 20, negative 40, negative 64. No, because there is a remainder of negative 64 when 2 is divided. Alright, next page. Here we have a nice long division problem, and it is a higher order degree than just 1, so that means we have to use long division. So I am going to set up my division bar. Let me straighten things out here. So as I'm writing my function, I'm checking to see, are we in descending order of the variable? Yes. Are we in descending order of the variable with our divisor? No, I need to have a placeholder. So x squared into 2x cubed is 2x. 2x times x squared is 2x cubed. 2x times 0 is 0. X squared. 2x times minus 4 is minus 8x. So we have, to show my subtraction. So 2x cubed minus 2x cubed is 0. 5x squared comes down. Negative 8 minus minus 8 is 0. And then there's my 1. So x squared into 5x squared is plus 5. 5x squared plus 0x. 5 times negative 4 is negative 20. So negative, 1, show my subtraction, or else I might mess up my answer. 1 minus minus 20 is not negative anything, it is positive 21. So I've got 21 over x squared minus 4 as a remainder. How many zeros does this function have? 5. And you don't have to name them here, you just have to know the fundamental of theorem of algebra is going to tell you how many zeros there are. So now we're looking at a graph, and how many real zeros? So we have 1, 2, and then right here where we have a point of inflection, that's actually a multiplicity of 2. So that's 4 real zeros. How many relative minima or maxima does it have? So here's a max, here's a min, and here's another max again. So that's 3. So the smallest degree possible would be a degree of 4, because we know we have 4 real zeros. And it has to be evens because they're both opening down, and so by noticing the end behavior of the graph we can see that we have a negative leading coefficient. Alright, in number 11, find the zeros of the function and state the multiplicity. So here I've got a 0 of negative 3, and I've got a 0 of 7. So my multiplicity for the negative 3 is 5, and here I've got a multiplicity of 2. Here I don't need to actually find the actual zeros, I just need to list them. Okay, so this is a signal that you're using the rational root theorem. Okay, that's too many humps on my M, but that's alright. So you're going to find your P's and your Q's. And remember, the P's are all of the possible factors of your last term. So the number 8 has factors of 1, 2, 4, and 8. And then the Q's are of your first term, so 5 is prime, so you just have 1 and 5. But then the idea is you're going to find all of the possible combinations of P over Q. And so we're going to go 1 over 1 and 1 over 5. And then 2 over 1 and 2 over 5. And 4 over 1 and 4 over 5. And 8 over 1 and 8 over 5. So there's the list of all the possible roots for that function. And thank goodness we don't have to find them since we're not using our calculators. So now we want to find all possible roots, or find all the zeros of each polynomial. So this would be one where if you're showing your work, this would be a calculator section, but you're only allowed to use the calculator to find 1 or 2 roots. You still need to use your quadratic solving techniques and synthetic division. So let's go ahead and take a look at the graph of this. And let me turn my plots off. And I'm going to have to change my window, but I'll do that in a minute. X to the 4th minus 5x cubed minus 6x squared minus 40x, no, not 40 squared, 40x minus 112. Let me change my window. I'll start with a standard window. And let's see if it crosses somewhere. Okay, so I have two potential places that it crossed at -2. And then this is positive 1, 2, 3, 4, 5, 6, 7. So those are the numbers I'm going to synthetically divide first. So I'm going to take -2, and then I'm checking, I'm going to do my synthetic, but I'm checking it all the way across to make sure I don't need a placeholder. So bring down a 1, -2, -7, positive 14, 8, -16, -56, positive 112, 0. Okay, so -2 works. Then I'm going to go ahead and use this polynomial that I have here to do 7. So 7 is 7, 0, 0, 8, 56, 0. So now I'm ended up with x squared plus 8 equals 0. And this is one of those where we end up with an imaginary root. So if I subtract 8 from both sides, I get x squared equals -8. Square root, square root. So x equals plus or minus call it I times the square root of 8. And then it really bothers me to leave a radical that's unsimplified. So that'll be 2 radical 2. So I had to find all the zeros. I did not have to list this as a product of factors. So here are my 4 zeros. And we knew in advance that we'd have to end up with 4, didn't we? So let's take a look at number 14. We've got 6x cubed plus x squared minus 4x plus 1. There's no GCF that can come out of there, so I am just going to graph that. 6x cubed plus x squared minus 4x plus 1. And let's graph it and see what happens. Alright, so I'm going to zoom in on this section right here because that's got some places where things are crossing, and so that's a zoom 2. Alright, so I crossed at -1, and then this is some fraction right here. So my rational root theorem probably tells me that it's 1/6, but I'm not 100% sure, so I'm just going to go ahead and divide out the -1. Use synthetic, and I'm checking, and I don't need any placeholders, so 6 times -1 is -6, that's -5, positive 5, 1, -1, 0. Okay, so now I end up with 6x squared minus 5x plus 1 equals 0. And so I want to see if this is going to factor. So 6 times 1 is 6. You need two things that multiply to 6 that add to equal -5. So that would be -2 and -3. Is that right? 6x squared minus 2x minus 3x plus 1 equals 0. So I'm going to factor out a 2x. That'll be times 3x minus 1 plus 1, no, minus 1. And then I'll do minus 1 times 3x minus 1. So I get 2x minus 1 times 3x minus 1. So it's good that I didn't just guess here, because actually I have two solutions here. I've got a half or a third, and so those are my three roots. I'll just write it out like this: x equals half, a third, and negative 1. You can't see that. There you go. In number 15, we've got, oh, okay, so this little thing down here is actually kind of a typo. It swung around down from number 15. So I'm gonna put that back where it goes and cross that out there. Alright, so I am looking for a root of number 15. So 2x to the third minus 5x squared minus 12x plus 30. Okay, let me zoom 3. So it looks like all of my zeros are decimals. So let me use the zero function to find one of them. Let's see, where's my cursor? There it is. Okay, enter, and then enter. Negative 2.45. So let me think about this for a minute. Okay, so what I did was a quick synthetic division with a negative 5/2, which wasn't an exact approximation, and it wasn't working out. So what I decided to do instead, this is just too messy of a decimal for me to figure it out, so I went ahead and looked over at the positive root, and that's a positive 2.5. So I'm going to go ahead and divide that one out. And actually I can go ahead and factor out a 2 out of my whole function. No, I can't. Never mind. So I'm going to do a 2, a negative 5, a negative 12, and a 30. And then 2 times 5/2 is 5. And then 0 is 0. And then 5/2 times 12 is times negative 12 is negative 30. So now I end up with 2x squared minus 12, or x 2 times x squared minus 6. And so that's why my decimal wasn't really working out over there on the other side, because the roots for this part of the equation are irrational. I get x plus the square root of 6 and x minus the square root of 6 when I factor. And so the square root of 6 is just a never-ending decimal, so you can't really plug that into synthetic division. So the zeros are positive 5/2 and plus or minus square root of 6 on this one. And then let's take a look at number 16. We're going to plug that in. We get x to the 4th minus 10x cubed minus 67x squared minus 116x minus 60. And when we graph it, let's see where it... So we've got two spots here where we have one that's a multiplicity of 2, And then we have another one where it crosses. So I'm going to zoom in on that. So it looks like it crosses right at -1. So I'm just going to start there. And again, double checking to make sure I don't need to have any placeholders. So I'm going to bring down my 1. 1 times -1 is -1. That's -11, +11, and let me get out of here. -67 plus 11, -56, times -1 is +56. So that's -60, and that's +60 and 0. Okay, so that one went in evenly. Now I need to go back and try to figure out where this other one was meeting. So it kind of looks like -2. But let me go ahead and check and see if that's a 0. So when I use my 0 function, I want to get my cursor. Alright, so there it is. So there it is on the left. Ah! Okay, that's not going to give me an answer. So I need to do it again. Second calc, 0. There's my left. I'd hit enter before it went all the way to the right. And there's my right. Okay, so it looks like it's about as close to -2 as I could possibly get, so I guess I wasn't looking at it correctly. So let's go ahead and synthetically divide -2. 1 times -2 is -2, that's -13. 2 times 13 is 26, so that's going to be -30 times -2 is +60. Alright, so there's my function, x squared minus 13x minus 30. And I'm going to see two numbers that multiply to be -30 that add to be -13. So 30 is 15 times 2. So there's a difference of 13 there. So I'm going to want my negative to be on the 15. So x squared minus 15x plus 2x minus 30. And we get x times x minus 15 plus 2 times x minus 15. So x minus 15 and x plus 2. That's just weird. Okay, so here I went all along and I'm looking at this graph here. And let me zoom out. And this graph has a cubic shape even though I had a 4th degree polynomial. So what did I do wrong? 10x cubed minus... So it's saying I should have these real zeros at 15, -2. Oh, alright, so there's a multiplicity of 2 at -2, and then 15 is not showing on the graph because of my window. Alright, so let me just bump that up to 20. And so that tells me that graph should turn around and come up. Yes, alright, it did. So now it looks like a 4th degree polynomial. So that's the kind of thing that we're trying to develop your graphing instincts to be able to know if you've made a mistake in the calculator or not. Alright, so number 17. We have to find another 0 given that 1 plus 2i is a 0. And let me just look. This is our last page, so I'm not going to stop and do a part 2 to this video. We're just going to keep rolling. So if 1 plus 2i is a 0, we know that 1 minus 2i is also a 0. See, I cannot synthetically divide or divide in any way this imaginary number into my polynomial. But if I take into account the fact that 1 plus and 1 minus 2i are both zeros, then I can FOIL that out. I get 1 squared plus 2i minus 2i cancels. Minus 2i squared. So that's 1 minus negative 4. So that's 5. So 5 should synthetically divide in. And rather, it's not 5, it's you know what, I have to take the roots of this. So if I do x minus 1 plus 2i and x minus 1 plus 2i, that's what I need to be multiplying. So I think I'm going to end up with x squared plus 5, but I'm not 100% sure. So that's why I'm going to check here. So I get x squared minus x minus 2ix and then plus 2ix. Those are going to cancel. So I can see from my other problems where I've done this, I can see what's going to cancel. So here I have plus 2i, here I have minus 2i, and then the minus 2i times positive 2i is a plus 4. So you can see here, like all these messy 2ix's and i's, they all cancel. And they actually leave us with x squared minus 2x plus 5. Okay, so this is the polynomial that I need to divide into my original to see what's left. X to the 4th minus x cubed minus 9x squared plus 29x minus 60. So that's going to go in x squared. That would be x to the 4th minus 2x cubed plus 5x squared. Subtract all that. Negative 1 minus minus 2. That's negative 1 plus 2 is 1x cubed. Negative 9 minus 5 is negative 14 plus 29x. So x times x squared is x cubed minus 2x squared plus 5x. So subtract all that. Negative 14 plus 2 is negative 12x squared. 29 minus 5 is plus 24x, and then bring down the 60. So that's going to be minus 12 minus 12x squared plus 24x minus 60. So when we have the identical polynomial, I know that when I subtract it, I'm going to end with 0. Okay, so x squared plus x minus 12, if that's what I need to factor, I think I can go, I need two things that multiply to equal negative 12 that add equal 1. So that's going to be a positive 4 and a negative 3. So I end up with a nicely factorable polynomial. So I actually can get all the zeros here. So there's the other, and if you could see what I was doing, that would make perfect sense. So there's the other 2 zeros that are missing from that polynomial. But you see, when you're given an imaginary 0, the key was to find the polynomial that doesn't have any imaginary stuff in it that you could divide out and get what's remaining. And number 18, we want a third degree polynomial with zeros of 4 and 2i, and then we are given an f of negative 1 equals negative 50, and we had one of those in the homework. So we are going to say that our polynomial is going to have some factor a, and then that's going to be times all the other factors. So we have x minus 4, x plus 2i, x minus 2i. And so we want to multiply all this stuff out and then use the fact that f of negative 1 equals negative 50 to figure out what a is. So let's go ahead and start by foiling our imaginaries. So we get x squared plus 2ix minus 2ix minus 4i squared, or plus 4 times x minus 4. So now I'll multiply these guys out. X times x squared is x cubed minus 4x squared plus 4x minus 16. So now I'm going to go over here. I'm going to show you this first. So that's where I foiled all that stuff out. So f of negative 1 is negative 50. So negative 50 equals, when I plug, so I've got a, and then I'm plugging negative 1 in for x, minus 4 times negative 1 squared plus 4 times negative 1 minus 16. Okay, so let me work this math out. A times negative 1 minus 4 minus 4 minus 16. So that's a times negative 25 equals negative 50. So divide through by the negative 25 and we get a equals 2. So our final answer is 2x cubed minus 4x squared plus 4x minus 16. Okay, and the last one is a Pascal's triangle problem. Okay, so the last problem, we need to use Pascal's triangle to expand this. So you can always just draw a quick Pascal as long as you know how to start it. So we start it with the 3 ones, and then you add up on the diagonals. So 1, 4, 6, 4, 1. So this is going to tell me what the coefficients are of my 5 different terms of this. So I'm going to have a coefficient of 1, and then I'm going to have so I've got an a and a b. So I'm going to have a to the 4th, and b is to the 0. Then I'm going to have a 4, and I'm going to have a to the 3rd and b to the 1. Then I'm going to have a 6, and a to the 2nd, 2a, and b to the 2nd. Then I'm going to have a 4, and I'm going to have an a to the 1st, and b to the 3rd. And then I'm going to have a 1, and I'm going to have a to the 0, and then b to the 4th. So once I've got that all written out, then I can go back and do the math. So 2a to the 4th, that's 16a to the 4th. And then for 2a cubed is 8a cubed times negative 5b. So I'm actually going to do this in 2 steps because I'll have to go back and multiply all that stuff. So 2a squared is 4a squared. Negative 5b squared is 25b squared. Then I've got 4 times 2a times negative 5 cubed is negative 125b cubed, plus, and then negative 5 to the 4th is 625b to the 4th. So now let me go back and get my final answer here, and I'll put it in a different color. So 16a to the 4th plus, so I've got 4 times 8 times negative 5, so that's 32 times negative 5, that's negative 160. So I shouldn't have even put the plus there. Whenever I have a minus in my original, I'm going to be alternating with plus and minus. So that's minus 160a cubed b. And then, since I'm alternating, I can go ahead and put the plus. So 6 times 4 times 25, well, 4 times 25 is 100, times 6 is 600a squared b squared. And then 4 times 2a, that's 8, times negative 125, which I think is minus 1,000, but let's see. Yes, okay, so again, I should not have put the plus there. Minus 1,000ab cubed, and then plus 625b to the 4th. So that is our final expansion. So I still think that's easier than doing 4 FOIL problems, but what you've got to recognize is that this technique, sure, you could do 4 FOIL problems, but once you get up into the pretty much anything higher than 4, 5, 6, 7, you're going to run out of time before you would have time to multiply all of those. So that's what the binomial theorem will do for you. And I know there's one of these on the final, there's one of these on your test, so if you have questions about it, make sure you ask them, or you can read the section in your book.